Hey guys, it's Mrs. Conway. So today we're going to go over how to use the elimination method of solving a system of equations. So when you're solving a system of equations, remember you're looking at where two lines intersect. The most obvious way to do that is to graph the two lines to find where they cross, but that doesn't work a lot of the time. For one, we don't just have graph paper. Sometimes the graphs are too hard to graph. So there's two different ways to solve a system of equations if you don't want to make a graph. The first method is substitution, which I went over already, and the second method is elimination. The cool thing is that all systems of equations can be solved with elimination, and all of them can be solved with substitution. So you don't actually need to know both methods, but it's good to have both because sometimes one is easier or the other is easier. So the elimination method is a way of solving systems of equations by combining the two equations to eliminate one variable. And when I say combine, I mean add or subtract. All right, so step one, make sure the equations are lined up. So if you look down here further on the worksheet, you can see y's are lined up above y's, x's above x's, and 4 is above the constant above constants. This method should remind you of adding numbers. Like adding long numbers. It's the same sort of idea, like you need to have your place values lined up, you need to have your variables lined up. Okay, so then step two, we're going to either add or subtract the equations to eliminate the variable with common coefficients. And then we're going to solve for the remaining variable. And then we're going to substitute our original answer. And this part is going to be a lot like substitution method. So steps 1 through 3 are specific to elimination, and then step 4 is the same whether you use elimination or substitution. And then we're going to solve for the other variable. So here's some examples. So honestly, this first one I probably would solve by substitution, but let's look at how I could solve it by elimination. Notice y's are lined up and they both have a coefficient of 1, right? So since it's the same number, I'm going to subtract. So same number, you're going to subtract. If it's opposites, then you add. Okay, so for instance, well, we'll see when we get down there, but I think an example of opposites would be question 5. You have 4 and -4, so those we would add. Okay, so I'm going to subtract these two equations just like we subtract regular numbers. So 1 minus 1y minus 1y is 0 equals, remember this is a 1x. 3 minus 1 is 2x. And then this is the part where you have to be careful because we're subtracting. It's 4 subtract -2, which is actually 6. So we have 2x plus 6, 0 equals 2x plus 6. Now we have to solve for x. So I'm going to change colors, subtract 6 on both sides. So I have -6 equals 2x, and then I'm going to divide by 2 on both sides. So -3 equals x. X is -3, which means if I have my coordinate point, I've got my x value. Now I have to find the y value. So pick either equation. I'm going to use the first one. Y equals 3 times -3 plus 4. That is -9 plus 4, which is -5. So y is -5. We've got -3, -5. And that's my answer. And I just might want to check it in the second equation. -3 minus 2 is -5. All right, so really quickly, think in your head for question 2, am I going to add or subtract to make a variable go away? And which variable would I be canceling? So hopefully you said, in your head or out loud, that you would subtract to cancel the x's because we have 1 x for each x. Notice the y's have different numbers on them. So I'm going to start by subtracting the two equations. X minus x is 0, which I'm actually, I'll write it down. But when we have more than one thing on the same side, you don't have to worry about it as much. And then 4 minus negative 1. Remember, you're minusing twice here because negative negative is actually going to be 5y equals 13 minus 3 is 10. So this 0 doesn't really matter because 0 plus 5y is still just 5. So then I need to solve for y. So all I have to do is subtract 5 on both sides. Y equals 2. Now I'm going to, see, this time I solve for y. It's not always going to be the same variable that you solve for first. And it doesn't matter which of these two equations you use to find x. I'm just going to grab the first one. I have x plus 4 times 2 equals 13. X plus 8 equals 13. Minus 8 on both sides. X equals, and then just a little check. If I put 5 for x, 5 minus 2 is 3. So it does work. So come over here. 5, 2 is my final. And that's really all there is to it. So why don't you, 3 and 4 are both examples of subtracting. Just like I did up here. Because you can see in 3, you've got the 2 3's. X's, they would cancel if you subtract, and down here you've got the 2 y's, they would cancel if you subtract. So what I want you to do right now is I want you to hit pause, and I want you to try and work these out. And then I'm actually going to pause the video and work them out and just show the work here real quick so that it'll move just a little faster. So give those two a try, and when you're done, hit play again. Alright, so hopefully you got these two answers when you did these two problems. So for the first one, for number 3, I got 8, 1, and for number 4, I got negative 2, 7. So you can take a look at that work there and see if it makes sense. Both of these I subtracted, then I solved for x. Well, actually for the first one I solved for y, and then I solved for x. So you're not always going to solve for the same variable first. It depends on which one you have left over. Then I solved for my second variable, and then I just check. So like for number 4, 4 times negative 2 is negative 8, plus 2 times 14, that's 2 times 7 is 14, so I have negative 8 plus 14 is 6, that's true. Negative 2 times negative 2 is 4, 2 times 7 is 14, 4 plus 14 is 18, so it works out. Alright, so let's talk about adding, and sometimes in some ways the adding ones are a little easier because you don't have to worry about that whole negative negative issue. So if you have opposites, you can add. So notice here we had 2 that were the same, so we subtracted to make one go away. If you have exact opposites, then you can just add to make a variable go away. Because like right here we have 4 and negative 4. So if I add these two equations, these will cancel because that'll be 0x, right? And then I can add these, which is 16y equals 16. And then divide by 16 on both sides. Y is 1. Now I can take my original equation, plug 1 in for y, so I have 4x plus 9 times 1 equals 5. And the biggest mistake people tend to make with these is forgetting what variable they're on. So we have a y here, so I need to plug it in for y. Just be careful that you're paying attention which variable you solve for first. So 4x plus 9 equals 5 minus 9 on both sides. 4x equals negative 4. Divide by 4 on both sides. So x equals 5 minus 9 would be, sorry, this pen writes funny sometimes. So I should have the point negative 1, 1 as my solution, and then I just want to come over here and check. Negative 4 plus 9 is 5. Negative times negative is positive 4 plus 7 is 11. So it worked out. So these are all kind of the same idea. We're adding, a variable cancels, and then we can check and make sure, or then you find the second variable. That's really all we're doing here. So solve for one variable, add them, solve for one variable, solve for the other variable. That is until we get down to number 8. So what I would like for you to do right now is to try numbers 6 and 7 on your own. Hit pause first, try 6 and 7 on your own, and then hit play, and I will show the answers for 6 and 7, and then you can try, and then we'll go over number 8. So hit pause right now. Okay, so hopefully you have completed 6 and 7 now, so just check your answers. For 6, I got -4, 3. For 7, I got 7, -3. So if you made a mistake, hit pause, fix your mistake, and then move on. We're going to move on to 8. So for 8, the rest of them really, notice we need to do step 1. Things aren't lined up here. So here we've got x, it's not over 2, x is, well, sorry, it is line, nope, right here, our equal spot's in the wrong spot. Equal sign is in the wrong spot. So this is x equals 3y plus 11, this is 2x minus 3y equals 16. So the problem is our equal signs aren't lined up, and that isn't okay. So I'm going to take this first equation and make it look like the second one. So I have x equals 3y plus 11. How is that different from the second one? Well, the 3y is on the wrong side of the equal sign. So to move it to the other side, I have to subtract it. So that gives me x minus 3y equals 11. So now I can take this equation and put it back over here. X minus 3y equals 11. So I have an equation that is lined up properly so that I can add or subtract. And then I just have to think about it. According to the rule, remember, if it's the same number, add. If it's a different number, subtract. And by the way, now we're kind of ignoring this top equation because we transformed it and moved it to the bottom. So now I have -3y and -3y, which means I need to subtract. So 2 minus 1 is 1x. -3y minus -3y cancels. Equals 16 minus 11 is 5. So 1x equals 5, so x equals 5. So then I need to take either equation and use it to find y. So I'm going to actually just take the first original unaltered equation and plug in 5 for x. 5 equals 3y plus 11 minus 11 on both sides. -6 equals 3y. Divide by 3. -2 equals y. So my answer is 5, -2. Just checking that. 2 times 5 is 10. Minus 3 times -2 is -6. So that's +6. 10 plus 6 is 16. And then this one was x equals 3y plus 11, which is how I got that in the first place. So that's how we do it if they're not lined up properly. Basically, you need to manipulate the equation so that they are lined up properly. Go ahead and give those the next 3. These, you don't have to do them, but I want you to give them a try. And then I will put the answers so you can see. So if you want to try the next 3, hit pause, and when you're done, hit play, and I will show the answers because I'll pause my video too. Okay, so hopefully you've at least had time to get stuck on 9, 10, and 11. So for 9, you might have had you first had to solve for y, or you first had to rearrange the first equation to match the second one. So I subtracted 2x on both sides, and then you just have to pay attention to, you put the x first and then the y, because that's what the first one looks like. And then I moved it up so that I solved it here, and then I moved it and wrote it underneath. And then I added, because I had a -4y and a +4y, so those cancel. Found that x is 4, and then when I put 4 in for x, I got 0 for y. So my answer is 4, 0. You can get a 0 as an answer. And then I just check that to make sure 0 equals 8 minus 8 is 0. 5 times 4 is 20, minus 0 is 20. And then the next two are kind of different situations. So in the first one, I looked and I was like, okay, well, I've got 3x and 3x. So if I subtract, that'll make those cancel. Well, that also makes the y's cancel. So I end up with 0 equals negative 10 minus negative 13 is positive 3. Well, that's not true. So that actually means there's no solutions. So if you get a statement that's not true, remember that's just like solving an equation. It's just no solution. And then 11 is also weird. First I was like, okay, I have to arrange this. So I moved the 2x to the other side by subtracting it. So I end up with negative 2x minus y equals 10. And then this one is 2x plus y equals negative 10. I moved it down here. So, okay, I can add to make the x's cancel. Well, that's 0x. Well, wait a second. Negative y plus y is also 0. And then 10 plus negative 10 is also 0. So I end up with 0 plus 0 equals 0. Well, anytime you end up with all zeros, that's infinite solutions. So our answer is infinite solutions. It's actually true for any equation that's on this line because it's actually the same line, just written different. So if you solve both of those for y and graph the line, you'd end up with the same line twice. So that is sort of the easy type of solving systems of equations by elimination. So hopefully you're starting to get an understanding of this. And then there is a Delta Math practice that you can start next week, or that you can start when we come back to full time. So good luck.